Alright, today we're going to continue with our logarithms, but now today we're going to start working with equations and simplifying and solving and things like that. And to do that we're going to use log laws. And log laws are basically just little tricks or ways that we can simplify or rearrange logarithms. So on your formula sheet there's 4 log laws listed, and they're the same as these first 3. And then you also have the very last one. The middle 3 are kind of just sort of special cases, and we'll look at those a little bit later on. So the first log law on your formula sheet is the product law, and it looks just like this. It's the same letter, same everything. But what we want to think of is, if you remember back to exponential laws, if I gave you something like x to the 7 and we times it by x to the 2, if we have the same bases, we would add exponents. So 7 plus 2 is 9. So the logarithm law works kind of the same, but it's backwards. So if we took a logarithm that had 2 numbers side by side, so that would be something like log of, let's say, base 3 of 7 times 4, what we're saying is that's the exact same thing as doing log base 3 of 7 plus log base 3 of 4. So the log law works the same both ways. So we can take a log that's together and split it into 2, or you could take one that's separate and put it back together. So quite often what happens is you'll sort of get the separate ones, and usually you want to combine them into one. So you sort of use the rule backwards. So let's go through a couple of these examples. So at the bottom here you can see we got a bunch of log 2's. They're all log 2's. They have to have the same base. And if that's the case, now that means we can just multiply all these things. So we'd have log 2, and we'd have x times x squared times y cubed. So we put all that together. X and x squared would give us x cubed, y and y cubed gives us y to the 4th, and we're done. So it's just a way of sort of simplifying or rearranging these equations. And sometimes it might be nice to actually work with these logarithms separately. So for whatever reason, if we had log 4 of 16 times 4, we could use this law backwards and split it up into log 16 plus log 4, both base 4's. And then we could actually solve this. So log 4 to the 16 is 2, log 4 of 4 is 1, so we get 2 plus 1. How do I know it's 2 and 1? Well, I'm sort of using the exponential rule. So remember from a previous lesson, we could actually rewrite these things as an exponent. So that would be like 4 to the x equals 16, so that's 4 squared, so we know x is 2. This would be 4 to the x equals 4, so we know x would be 1, so 2 plus 1 gives us 3. The next log law that's on your formula sheet is much the same, except it's the quotient law. So just like exponents, once again, if I gave you x to the 7 and I told you to divide it by x to the 4, we would subtract those to get x equals x to the 3. So using the same logic again, if I gave you something like log base 3 of 21 divided by 4, we could break that apart to be log base 3 of 21 minus log base 3 of 4. So if they're dividing inside the log, they'd be minus outside the log, just like the addition one, but the other way around. Okay, so let's kind of look at the same sort of example here at the bottom. We got log 2 of x minus log 2 of x squared. So because it's minus, we can write those as division, and x divided by x squared would simplify to 1 over x. Or once again, we can work backwards. So if I gave you log base 3 of 81 over 27, we can split that up into log base 3 of 81 minus log base 3 of 27. And once again, 3 to the what would equal 81. So that's 3 to the 4. 3 to the what equals 27. Well, that's 3 to the 3. So 4 minus 3 would give us just 1. So all of that should equal just 1. Okay, the next one, the power law, it's kind of like exponents, but a little bit different. So if you think back to exponents, what the power law looks like would be something like 2 to the 4 to the power of 3, and we would just multiply those together to get 2 to the 12. In terms of logs, it's a little bit different, because normally how it's going to be written now is we'd have log base 2 of 5 to the power of 3, or something like that. So that log law, instead of, we only have one exponent, so instead of sort of multiplying it, that 3 gets multiplied by everything. So it ends up being 3 times log 5. So we were just basically taking that front, or that exponent, and moving it to the front. So if we look at these examples, we see we got an exponent of 2, we bring it down in front, so we get 2 log 2 of x, and that's it. And we can work backwards, or the reverse. So here we have log 3 of 81, root 81. Remember, root can be written as to the power of 1/2. So log 3, 81 to the half. Then we can bring that half down in front. So 1/2 log 3 of 81. 3 to the x equals 81. So that means it's 4. So we get 1/2 times 4. 1/2 times 4 is just 2. So a lot of these log laws are just going to be used to help you simplify and rearrange equations. The other ones that show up that are handy, this is a way to split up a log. So if I gave you something like log base 2 of 7, it's just a decimal answer. So what this rule is saying is we can actually rewrite that as log base 7 over log base 2. And here you can see we have a different base. So we can change the base from 2 to something else as long as they're the same. So what we're going to do is use this one quite a bit, and we're going to use log base 10 because that's what our calculator is programmed to be. So if you have something like log 2 of 7 on your calculator, you can just type in log 7 divided by log 2, hit equals, and it'll give you the decimal answer. So this is a handy one that we're going to use quite a bit. And the last ones are just sort of special cases. So if we have log b of b, so any number of itself, so if I gave you log 4 of 4, remember we could change that to a exponent. So we could write that as 4 to the what equals 4, which would be 1. Or we could even use this new rule. We could write that as log 4 over log 4, which is 1. So any log by itself will be the same. So if I give you log 7 of 7, that's also going to be 1. Log 9 of 9, that's also 1, and so on. The next one is kind of the same, except it's log b of 1. So if I gave you log b of 1 and we change that to an exponent, that would be b to the 0 equals 1, which is true because anything to the 0 is 1. So 3 to the 0, 5 to the 0, 10 to the 0, it's always equal to 1. So that means if you have a log of 1, you're always going to get 0 for an answer. And the last one, it's kind of a weird one, but if we change this to an exponent, we would have base and then crisscross, you'd have a to the x equals, log base a. So log base a of x equals log a of x if we do our crisscross. So you can see those are exactly the same thing. So that one's indeed true as well. That one you're not going to use as much. This division one is a big one, and then also remembering that log b of b, 7 of 7, 4 of 4, whatever, is always equal to 1. Those are the main ones. Okay, so let's expand a few of these. So we're going to use the log laws and work one way, and then we'll do some going in reverse. So in this case, we want to expand these out. So that means we have log base 4. You can see we've got x cubed. So let's separate the x cubed. We're timesing it by y. So that would be the same thing as plus log 4 of y. And then we're dividing by 4z. So that would be the same thing. Let's break the 4 and the z apart too. So we're dividing, so that'd be minus log 4 of 4. And we'd also have minus log 4 of z. And that's it. So we just broke it all apart. We could do a little bit more simplifying. We can use that exponent rule. So the first one could be written as 3 log 4 of x. And the rest would basically stay the same. Log 4 of y. Log 4 of 4 we know is just 1. And we have log y of 2. So that one, that's about all we can do. So we're not really making anything easier. It's just using the rules to help us split these up a little bit. Okay, let's try the next one, and I'll do it down below here. So log 5 of root. Remember, this root can be written as a half. So that's an important thing we want to do. And let's get rid of that half onto each item. So let's rewrite this as log base 5 of x to the 1/2. And then we have y cubed to the 1/2. So let's write that as y to the 3/2. Just FOIL those out. And now we're ready to expand it. So we'd have log 5 of x to the 1/2 plus log 5 of y to the 3/2. And we can use that rule where we bring it down in front. So that'd be the same thing as 1/2 log 5 of x and 3/2 log 5 of y. Okay, so that's it for that one. Let's do the last one. So this one's kind of the same again, except we got a division, and we've got a few things going on here. So let's get rid of this cube root. So we'll write that as 1/3. So now if we break this apart, we'd have log, this is base 10, so we have log base 10 of 100 plus log base 10 of x to the 4/3. And then we're dividing, so that'd be minus log base 10 of y squared. So just like we did before, log 10 of 100, we can simplify that to be 2. Bring the 4/3 down, so 4/3 log base 10 of x. We don't need to put the 10 in. And the last one would be 2 log base 10 of y. And that's it. Because we don't know what the x's and y's are, we can't really simplify those any further. Okay, more commonly you're going to get logs and you're going to work backwards. You're going to put these together as one logarithm. So let's use sort of the same rule here. So we've got log 2 of x cubed, so that's good. We've got log 2 of x, but we've got that 4 in front, which messes this thing up. So let's bring that 4 up as an exponent to get rid of it. So now we have log 2 minus log 2 minus log 2. They're all good. And let's even write this one as x to the half, make it a little bit easier. So now using our rule, we'd have log 2, we have x cubed. Then we're minusing, so that'd be dividing by x to the 4th. And we're minusing again, so that'd be dividing by x to the 1/2. So if we simplify all of that, we have 3 divided by 4.5, so we go 3 minus 4.5, which would give us negative 1.5 or 3/2 as a negative. So we can write that as 1 over x to the 3/2 if we want, or we could write it as negative. It doesn't really matter, but we got it together as one log. Okay, let's do the same thing for this last one. So we got a 4 there. Let's bring that 4 up. So in this case, we'd actually have log 6 of y squared, and y squared to the 4th would be the same thing as y to the 8th. And then we got log 6 of y. And let's bring the 2/3 up as well. So we have log 6 of y to the 2/3. And it's a minus, not a plus. Let me fix that. And that's it. So we've got all of our log 6's. So we can put all those together. We'd have y to the 8th times y divided by y to the 3/2. So y to the 8 times y would be y to the 9, and then 9 minus 3/2. So 9 minus 1.5 is 7.5. So we can write that as log 6 of y to the 7.5, which would be 15/2 if we leave it as a fraction. And we can put brackets on, or you don't need to. It doesn't really matter. It works the same either way. Okay, so that's it for that one. Let's do a couple more. So these are the same sort of thing again now, but we actually have numbers, so we can solve it to actually work out to a regular number. So if we have log 4 of 8, we're adding, so we can combine those to be 8 times 32. So that gives us log 4 of 8 times 32 is 256. And let's solve that. We can basically ask ourselves 4 to the what is 256. So if we go 4 to the power of 6 is too big. If we guess at 4 to the 5, still too big. 4 to the 4 is 256. So x equals 4 is the correct answer in this case. Okay, the last one, log 6. And let's use the rule of 216. We'll use that, and then we'll split it up into log 6 of root 36, but it's a 4th root. So that would be 36 to the 1/4 if we wrote it like that. So we can simplify log 6 would be 6 to the power of 3 is 216, so that one's equal to 3. And this one, let's simplify it. Let's bring the 1/4 down in front. So we'd have 1/4 log 6 of 36. Log 6 of 36 would be 2. 6 squared is 36. We'd have a 1/4 times 2. 1/4 times 2 is a half. So we'd have 3 plus a half, which would give us 3.5, or we could write it as a fraction as 7/2. And that's it.